Okay. Why I'm not still seeing live? I think they're live. Okay.
All right.
Yeah, I think. I'm not sure how people join.
Yeah, looks like we're live.
Yes. I want to see if people are joining.
I can see 6, 7 coming in.
All right.
Yeah.
Okay. So I think hi. You're ready to go live with Pio. Pio is a fellow MVP in data and uh, Microsoft data platform, SQL and data platform, and he's based out of Singapore. So over to you, Pio, and have a good session.
All right. Welcome everyone to Global AI Bootcamp 2021 here in Singapore. For those who have been here since yesterday, I hope it has been a very worth. I hope it was worth your time. I was looking at the schedule. We still have a lot of interesting uh, sessions happening today. So if you want to stick around and check out the sessions later on, make sure you check out the playlist on YouTube. In this session, hang on, let me just hide this one. Okay. In this session, we're gonna talk about AI and ML in SQL Server 2019. I am I'm Pio Balistoy. I'm a lead Microsoft data platform consultant for Pythian Services. Pythian Services is a managed services provider based in Canada. We help our clients manage and utilize their data efficiently in this day and age of digital transformation. I'm also a Microsoft MVP for data platform based here in Singapore. I help organize the SQL Pass, well, the group formerly known as SQL Pass Singapore chapter. SQL Pass was dissolved yesterday. It's the last day for the org yesterday. So we're in the middle of a rename. We're likely gonna be we haven't decided, but we're likely be Singapore Data Platform User Group. You can check us out on Facebook. We have a Facebook group, and we are in the same meetup group as the Azure and data communities here in Singapore. I also help out in the Philippine Data Platform Forum, the group formerly known as SQL Server User Group for Philippines. If you wanna reach out to me after this session, if you wanna talk about data, about SQL Server, you can reach out to me through the social media channels that you can see on the screen. I've been working with databases for more than 17 years now. 17, 18 years now. I've always been a database. I'm a SQL guy. So yeah, that all those logos at the side is also me. That's enough about me. Our agenda for today is about machine learning services in SQL Server 2019, how you can do ML in database, and the features that SQL Server has. If we have time, because I've been trying. When I do this session, it's usually more than an hour, but we will try and squeeze it in. If we have time, we're gonna take a look at how you can do AI in SQL Server 2019. And then if we really are very fortunate and we really do have enough time, we're gonna take a look at big data cluster. But I'm not promising anything because the last time I checked the runtime for this session, it's I think we only have 45 to 50 minutes, and that's more than that's just enough for the ML part. So let's see how it goes later on. Whenever I do an AI or an ML session, I always want to start with this number 44. I'm not sure if you have seen this in any of the sessions earlier about ML or about AI, but 44, that's the magic number right now. 44 zettabytes. So that's 44 with 21 zeros after it. To put that in context, the estimated number of stars in the universe is 1 zettabyte. So that's 44 times the the estimated number of stars in the universe. That's how much data we have generated in 2020. So that's a lot. If you look at in a day, right? Here is an estimated number for a day of data that we produce in a day. If you look at it, it's staggering. The Gone are the days that data is limited to information that you can fit into a table inside a database. Right now, data comes from various sources, from your traditional user transaction to product telemetry to social media channels and to your smart devices. Just for example, wearable devices on 2020 produced 28 petabytes of data. That's a lot. If you look at the history, back in 2013, we only produced 4.4 zettabytes. We're already in the zettabytes region, but just 4.4 in just what 7 years. That's we've more than not just doubled. It's 10 times the amount of data that we produced back in 2013. So with this explosion of data, we also have wide range of data format that we have, from relational to non-relational, from different types of files to structured and unstructured. So, and it's all because of the advancement in storage and compute capability brought about not just by the cloud but by the recent developments in technology. If you take a look at machine learning, which we are going to talk about today, eh, it started in the 50s, right? When someone from IBM, Arthur Samuel, created a program that can do checkers. Uh, but from there, if you take a look at the history and the development, the rapid changes and improvement in AI and machine learning happened in the last decade, in the last few years, in the recent years, because of the economy of scale that cloud provided in terms of storage, aside from the advancement in storage, and also the compute capabilities that we have today. With all these data, various data sources, and this much data we have in hand, it also brought about new set of problems, as well as magnified the existing problems that we already have in the business, uh, in all businesses even before. So right now, with since you have multiple data sources that you have, integrating your data from these data sources becomes expensive in terms of resources and time. You now even before we have big data, or we have this amount of data that we retain and we can use, we already have siloed relational data within a company or even within a department. You have various databases that are separated from each other. So with the amount of data that we have now, it becomes more of a problem on how you can integrate this data so that it can be useful to you and to your business, because having that data is worthless if you cannot use them. So the data being siloed is another problem. How you manage the security for all this? If you have multiple sources, you need to manage the security on all of them. If you need regulatory compliance, if you have regulatory requirements, you have to make sure that all your data sources meet all of these for your data to be secure. So it it is a it provided us with a great opportunity to do AI and ML, but it also sometimes becomes a barrier on how you can do this, how you can integrate your data sources from the cloud, on-prem, from different technologies, and how you can secure them. And that's the premise that I want to talk to you about today. SQL Server 2019 wants to be the hub for all your data, whether it's your transactional data from your application, or whether it's your analytics requirements. It wants you to do all your data processes within SQL Server itself. SQL Server has a lot of features that will allow you to not just query but join your external data, no matter what relational database it comes from. For example, Oracle, your data warehouse, the cloud, Teradata, or whether it's structured or non-structured data, or even if it's if the data is from your Hadoop or your blob storage or your file system, SQL Server now allows you to integrate those data and do your processes within SQL Server itself. So, taking a look at the features that 2019 provides for you for your AI, ML, and big data needs, we have Polybase. Polybase allows you to create external tables, so you can write your T-SQL queries. You can read the data from your various data sources, external data sources, be it an HDFS or a different relational database, or Hadoop or NoSQL sources. You can now create external tables and query it like your native table within SQL Server. So it doesn't need you don't need to move your data anywhere. You can utilize them. You can use them for your big data requirements, for your analysis within SQL Server itself. And then we have big data clusters. Big data clusters, it leverages containers and Kubernetes, so you can have enterprise scale. You have a highly scalable cluster of SQL Server, Spark, HDFS. This allows you to combine your relational data, your highly valued relational data within your SQL Server, with your big data, with the high volume big data that you have outside of SQL Server. Uh, so it's easier to integrate and scale out. And then the topic that we're going to talk about today is machine learning services. So machine learning services provides you with with a framework, with an extensible framework that allows you to do machine learning within your database, in your relational database, without moving your data, using the language that you prefer. If you're a data scientist that uses R, you can use that. You don't need to relearn another language or you relearn another IDE. You can use what you have been using, your Jupyter notebook. Use R, use Python, or use Java, and do your machine learning services within T-SQL Server without worrying about your ETL, your ELT, or your integration, your data integration. You can do and perform your machine learning task within the relational database. And then the last one that we have is machine learning server. This is for your enterprise scale platform for machine learning. If you want it separate from your SQL Server, a completely standalone server for machine learning. And that's what we're going to talk about today, machine learning in SQL Server 2019. Before we go to that, let's take a look at the two methods of data integration that we have today. If you have data from various data sources, you have two ways you can go about it. You either move your data using data movement, using integration, move the data from your source to where your analytics where you require analytics. So you create a copy of your data and you move it to your analytics server. The problem there is you're duplicating your storage, you're duplicating your data, you're doing data movement. You need to worry about your ELT, how you move the data. And since you have data on two places, it makes your security effort and like I said, if you need to follow regulatory requirements, you need to make sure that both, not just from the source, you need to make sure that your analytics server also adheres to the same policies so that your data is safe and secure. The other option is data virtualization. In data virtualization, you query your data during runtime. You don't copy it over to wherever you want to use it for your analytics, for example. What you do is you virtually represent that data from the source to your analytics server. So you don't replicate your data. You don't need to worry about where your data is. It stays at the source. You don't move it. You don't need to worry about integration. You virtualize it. That's the other way. So why might we want to do AI ML or machine learning in database? In terms of enterprise need, like I've been mentioning, some you a lot of most companies right now need to follow regulatory requirements in terms of security and privacy. So because of that, it might limit your capability of moving your data all around. You need to adhere to these requirements. So it makes it easier if you're doing it in database. You don't need to worry about other data sources or where your data is going, because you keep it within the database itself. It did not move, so you don't have to worry. Uh, and some companies might not be able to load data into the cloud because of the same thing, security concerns, right? Or company policy. You might not be able to load data into the cloud, or by simply infrastructure. Not all places can do has internet high bandwidth internet connection to the cloud, for example. So those restrictions might even though you have those restrictions, you might have needs for AI and ML. In those scenario, you can do it. You might need it. You might need to do it in your database without moving your data. In terms of customer, right? It's the same thing. It all boils down to control over your data, where your data is going. So when you're doing it in database, you have more control. In terms of model, you have more control in the updates and the changes on the versioning of your model if you do it in database. So those are the high level reasons and advantages of doing it in database. Right now, if we look at the traditional way of doing machine learning, what usually happens is you have an application and your OLTP database, your transactional database. So all your user transactions from your application goes to your transaction to your database, to your OLTP. And then if you want to do machine learning or AI, what we do is we move that data to your analytics server, and there you will do your transformation and model training to create your model. And once that is done, you need to create another API or another service or another logic to embed your model to so that you can use it for scoring. And in terms of scoring, the data that you move to your analytics server is likely not the entire data from your database. Oh, you normally don't do that. You normally just get a sample of the data that you move to your analytics server, and then the new data that comes in to the application, it goes to your scoring, and that's the only time that you can serve predictions to your application. If you look at this flow, you can see there's a lot of data movement happening. So the same issues that I already raised earlier, you need to worry about your integration, the movement of your data, the storage of your data, the security, the regulatory requirements, the policies that you have to govern all this data, not just on your source but on your analytics server and wherever you might transfer it in between. Now, uh, what SQL Server 2019 wants you to do is you have your application, you have your transactional database here, your SQL Server. What it wants you to do is your user transaction goes to your OLTP, do all your transformation, do all your model training, do all your scoring within the database. You don't need to move your data. Do your model training here, create your model here, and once you're ready, just serve your prediction back to your application. No need to create any separate service, any embedded logic. Your application can get the prediction the same way it communicates to your OLTP by TSQL, by stored procedures, the same way it can receive the prediction. No need to create another infrastructure to handle it. That's what in database machine learning is trying to uh, uh, that's what in database machine learning is. So in terms of processes, it creates better collaboration between your teams in your in your team on your data science process. For example, your data scientists can explore the data within SQL Server using the IDE that they are used to. For example, if your data scientists are using Jupyter Notebook, they're using R, Python, Java, they can use it. They don't need to learn T-SQL to query the database. If they want to do T-SQL, they can also do it. They can do the training remotely on SQL Server. Use T-SQL stored procedure. Embed your R script. Embed your Python script. Create your Java packages, your Java jar files, your Python packages, and execute it through T-SQL to train your data. No need to move. And then when you're ready to deploy, you can deploy it from Python itself, from R itself, if that's where you want to do it, from Jupyter Notebook if the data scientist wants to deploy their models, or you can throw it to your SQL developer, your SQL DBAs, for them to create the T-SQL stored procedures, so that so that the application developer can consume it, not just for the model training. Just going to step back a bit, you can store all your models within the database itself, so you can manage your model versioning in database, and they have the option. And then your SQL server, your SQL developer or your DBA can also create the prediction stored procedure, so that your app developer can consume the machine learning model that you created. It's gonna be a simple stored procedure call. No need for another service. No need for another API, so that you can serve your prediction. Yeah. So just stepping back a bit and sharing you the history of ML services on SQL Server, and later on extensibility. So in 2015, Microsoft acquires Revolution Analytics, and that gave way to their AI and ML capabilities. Uh, that's when they came out with R server. Later on, it was renamed to machine learning server, but before it's called R server because it can only do R. And then from there comes the SQL Server ML services for R. So you don't need a separate server. You can do it within the SQL Server itself using R. And the reception was quite good. It improves the processes for the data scientist, for your data engineer, using R. So they on 2017 they came out with ML services for Python. So now you can use R, you can use Python within SQL Server itself to do your ML task, to do your data operations, which makes it very useful for data scientists and data engineers alike. To improve the usability and to extend the capabilities of ML services, on 2019 they come out with Java extensibility. So now you can use R, ML, and Java. And the introducing Java changed a lot of things, because you don't just use Java for ML. You can do a lot of other things using Java, and that's what we're gonna take a look later on for AI. Yeah, for AI. And when they introduced Java extensibility, they also introduced the packages. Now you can store packages and libraries within SQL Server itself, which made it very useful, not just for your data scientists but for DBAs, for developers, because and data engineers, because you now can do more things, not just machine learning. Whatever you can code, if it's easier to code in Java, if it's easier to code in ML, in R or in Python, you can do that and create your own libraries. So let's take a look at the infrastructure first before we take a look at the script on how you can do it. So for machine learning services, there is a service called Launchpad. So the T-SQL goes to SQL Server. If the story procedure will specify what kind of script you're running, if it's Python, Java, or R. What happens is SQL Server will call Launchpad. Hey, this store procedure has R, has Python, or has Java. It will call the Launchpad, and the Launchpad will launch a satellite program for the language that you used. For example, if you're using R, it will launch a satellite program for R, satellite if you're using Python, satellite program for Python, and then so on. These satellite programs have direct communication to SQL Server. They can query the SQL Server. It's using TDS, but all these the satellite program and the Launchpad, they are completely separate application and process from SQL Server. So it has its own memory consumption. It has its own compute resources. It's on a different process ID. It's a different app ID. It's completely isolated from your SQL Server. So whatever happens on your satellite program, it won't affect your critical transactions on the SQL Server. It won't affect SQL Server. It won't bring down your SQL Server. If, for example, if it crashed, then it will just crash the satellite program for R. And what happens is the next person that runs R will just launch another satellite program for R. It's completely isolated. So there's no concern about it affecting your transactional database. And this is how you can do it. There's a script called SP execute external script. I think we can take a look at it much better if we do it on SQL Server itself. So my goal for today for this session is to show you that you can do machine learning service in SQL Server. So I won't be going deep on how you do machine learning or how you can create your model, how to code it in Python, because most of you in this stream will likely be better at me at Python. I'm a SQL guy, so I'm just gonna show you guys that you can do this in SQL Server. We won't be diving deep into how you can do your how to do linear regression, how to do all those other classifications. I'm going to show you that you can do it on SQL Server. So this is the script. This is the SP execute external script. The most basic part is the language in the script. So the language is specify what type of language are you using. Now, this is the same whether you're using R or Java. The parameters will be the same. So exec execute external script. The language is Python. The script, and this is your Python script. So here I'm just going to use a simple example of Python. So if we run this, it will launch the Launchpad will the SQL Server will call Launchpad, and then it will launch SQL a Python satellite program, and it will run the script. So here we go, 7. That's what it did. So the SP execute external script allows you to also have input data set for your Python script. So the language, the script, and then there's a parameter called input data 1. That will be the input for your Python script. So the default name for the input is input dataset. The default name for output is output dataset. So the input dataset that you will pass to your Python is a SQL query, because you're querying data in database, right, within your SQL Server. So you select this, the select query that we have, the T-SQL query. So when you execute this, it will give you the output. We're using select 1. We're just passing it to the dataset, so it's just gonna return your dataset, which is 1. And then I said this is the default name. So for your complex need for Python, you likely need to have names for your data, for your input output. So you can also do that. You can rename the input output. We just use these parameter at input data 1 name, which is I rename my input data set to my input, and then I rename my output data set to my output. And then this is the select command, the T-SQL command. So once you do that, you can use the variable names, the input output names on your script as you like it. So that will just still give us the same one. And one thing you notice, the data set that it returns doesn't have any column names. it doesn't we specify here select one as foo, but it doesn't say foo. So the data set itself doesn't have column name. What you can do is you can format the results with this command. So it's the same parameters, the language script, and then the output data. Uh, the output data, we rename the output data, we rename the input data, and then the result sets, we formatted them with this with this uh, with this command. So with the result sets, I renamed the column, my column name too. So if it works, then one should be my column name and two should be my column name too. So if we execute that, there you go, my column name too. So you rename your columns. Now, by default, the output data set is in Panda data frame for Python. So if you wanna format a result set, for example here, I have a variable C, one half variable D, one times two, and I want to output this to my execute external script. I need to format that first into a Panda format because that's the format that the output data set will be. So this is how you do it. You just import pandas as PD. You can import libraries into your script, and then you declare the output to be df. So this will turn it into a table, into a data set. Oh wait, sorry, into a data set. So there you go, one half, point five, and two. So another way to do it is like this, but it's the same thing. It's a different conversion. Well, it's a different way of converting it in Python. But column one is 1, 2, column two is 3, 4. So once you execute, you have here 1, 2, and 3, 4. So that's the basic for the SP execute external script. That's how you can call Python script. So if you want to use R, you just change it to R and then write a script for R. And the same thing with Java. And the other thing is, for you can also do packages, not just plain script. You can create packages. So by default, the algorithms that you can use for on ML services are these five type of algorithms: classification, regression, clustering, anomaly, and reinforcement learning. By default, because we'll talk about it more later on. So what do you need for you to be able to do machine learning services in SQL Server? So it's not installed by default. You have to choose to install it during installation, or you can add the feature afterwards if later on you decided to use it. Just a note: machine learning services is different from machine learning server, as we highlighted earlier. So I just want to show, because there are some confusion for some people when you do the installation. Let me just yeah, here. If you look here, when you do the installation, the machine learning services will be under the database engine services. These are the two. So you can choose to install R or Python or both if you both did it. That's the machine learning services for in database machine learning. If you want to install a separate standalone machine learning server, that's on the shared features, that machine learning server. So this is a standalone server. It's completely separate from SQL Server. It's a separate process. So if you wanna do ML server without SQL Server, if you wanna do an enterprise at scale deployment of machine learning server on prem, you can use that machine learning server. And then before you can execute any external scripts, you have to configure SQL Server to allow it. So you need to run sp-configure external scripts enabled one, then run reconfigure so that you can run external scripts. There are a few methods on how you can run models. One is the first one that I show you, the extensibility framework, the SP execute external script, because with that SP you can execute Python and R and Java scripts or packages. So you can use that to run your model. Or since 2017, SQL Server actually has predict T-SQL function. This is T-SQL native. You don't need to install machine learning service. But by default, the only model that it can do is the ones that I showed you earlier. Only the supported algorithms from RevoScaler are, or packages that you develop using RevoScaler, models that you develop using the RevoScaler R package. There is also a wrapper, T-SQL wrapper for RX Predict. So there's SPRX Predict, which is it can wrap the RX Predict function in R in RevoScaler and Microsoft ML, as well as the RX Predict function in Python and Microsoft ML, RevoScale PY. And then the last, the another way to do it is using big data clusters, because big data clusters has ML services. So you have ML processes. You can do that on your BDC. And aside from that, much more than that, actually, BDC can also do Spark. It also has Spark environment for your Spark R or PySpark. Spark ML needs or libraries for machine learning over your HDFS and database data. So if you need more enterprise way or at scale, if you have more complex needs, then you can do with you can go BDC instead of just ML services. I just want to show you guys the predict function. It's just like this: predict, and then you specify the model that you stored on the database. For example, if you store it on the database, and you can use that to do your prediction. So let's take a closer look on how you can do uh, machine learning model and machine learning, how you can do machine learning in SQL Server. So let me just this one will be very quick. Let me just restore my database. So I have here this is Azure Data Studio. If you haven't used this tool, make sure you check it out. It's very useful. I'm uh, I'm a DBA, so I'm more attached to SSMS. But when I saw Azure Data Studio, it has a lot of capabilities. It allows you to put it brings the notebook experience to SQL Server because it has SQL kernel. So let me just make sure to check it out. It's a free tool from Azure. So I'm just gonna restore my database. I have a tutorial DB here. We're gonna take a look. It has all the rental data for a ski resort. So we're gonna try and do a linear regression model for predicting the rentals for the year. So it has all the data here: the holidays, the snow, the rental count for the day or the year, the month. So if you're a data scientist, right, you want to use Python. So I'm gonna switch to Python so that we can do that. Changing kernel, loading text. So let me just. So here, I'm not gonna go into detail on how the linear regression or the Python script works, but I'm just gonna show you that you can do it on SQL Server. So below is the script, the Python script. I'm gonna input the data from my database from the tutorial DB. I'm just gonna format it into a Panda data frame so that I can use it to train my model. So there you go. And then I'm gonna use that to train my model using linear regression so that we can predict the rental count. There you go. And then since I'm still in Python, right, I can do a prediction using so that we can predict the rental count using the lean model that we created on the first script. So here, so if you're so you now have a model that you can use for your prediction, right? Now the next thing to do is bring it to your application so that they can use it. If you're using traditional way of doing machine learning, if you're not doing in database, then you need to create your service or your API, or your REST APIs that will call your model, right? But here, if you're, for example, if I'm a data scientist, I want to turn it into a T-SQL stored procedure. I have a I have here. It also has the facilities for you. SQL ML has a SP as a function, creates sproc from function. What it will do is it will convert this function, train model sproc, into a T-SQL function, T-SQL stored procedure named Python Gen Rental PY model. If you're more comfortable with Python, then you can use this. If you're more comfortable with SQL Server, then you can, or T-SQL, you can actually go to SQL and then create the SP on SQL itself. So let me just change to tutorial DB. So I'm gonna drop and create my. This will create my external script. See, I wrap SP execute external script into a stored procedure. So on the SQL side, on the database side, I'm just gonna need to call this store procedure, then it will do the Python script. So, and for in database, what we can do is we can create a table within our database where we can store our model. This is very useful because this means you can store multiple models in your database, and you can manage your version more efficiently in database without going to anywhere, and then you can reuse and use whatever model version you would like to use for your predictions. So that's there, and then now we're gonna create the model. So what I'm doing is calling the SP that we just created, that will call the Python script. Then it will create a model for us using linear regression. So just wait, just taking a bit of time. There you go. And if you go to the model table that you created, now we have one model there named linear model. So now we have a model. Now, and we have a stored procedure that can create models for us in the future. Now we need to create a SP that will make the prediction for us. So here is the SP. It's the same thing. I'm gonna use the Python script again to do the prediction. So this will be py predict rental count. I'm gonna create it on the database itself. So it already be created. So now you need to create a table for storing your prediction. So first, let me just so aside from storing your model, you can create a table where you can store your predictions in the database itself. So what I will do is I will just call our py predict rental count, the SP that we created for prediction, and then pass the name of the model that I would like to use. For example, if I have multiple models there, uh, you can pick and choose whatever the model you want to use. So I'll pick the linear model, and then I'm gonna, oh, sorry. There you go. And now here's our prediction. So here's the actual. This is our prediction. It's very close since it's and that's how you can do machine learning in SQL Server. You can create your script in Python. You can create the SP in Python. You can create it in SQL Server, whatever the language you are more comfortable with. And for example, if you have multiple teams handling it, your scientist can create the script in Python. They can create the model. They can just pass it to the to the app developer without them having to need to learn how to read the model or how to do Python. They can just call it through TSQL. Okay, so in terms of Security and governance. It has a reduced surface area because it's isolated. Like I explained earlier, the scripts, the script execution for the ML languages are outside of SQL Server. It's not using any of the SQL Server processes or resources, so it's isolated. You need to enable the external script capability of the instance for you to be able to use it. So you can control it if you want to turn it off, turn it on. You have control. In terms of scripts, you need to have explicit permission to execute an external script if you want to do this. If you're not an SA, and you need to have permission, of course, on the underlying tables and database that you will use. In terms of Python processes privileges, it is very limited. Like I said, it runs isolated from the other services of SQL Server. But as on top of that, different users use different AMP containers. So even in terms of user, it's isolated per user. So it's very a lot secure. Now let me go back. Yeah. So as you have seen, we didn't need to do any data movement. We didn't need to move any data sample. We can reuse the data that we already have on our database. There's no sampling that needed. You can work remotely from your dev environment. You can leverage the power that SQL Server has, and uh, as I will show you later on, you can utilize any open source package in database, and then you combine the best of both worlds, the open source and the MS options. So you can use the open source packages within SQL Server, or you can use the packages that SQL Server has with Microsoft ML or Revoscaler. And then the version management of your models will be in database, easier, and it streamlines your operation without your team depending on each other. Like I said, for example, for your app developers, they don't need to have any knowledge of the models. They don't need to understand Python. They just need to consume it by calling tsql. And the same thing for your data developers. They can leverage their existing skill with R and Python for data visualization and for data processing using the script that they are comfortable with within SQL Server. And yeah, so in terms of extensibility, it goes beyond that. It goes beyond ML because you can use it for other data visualization usage or other data processing that you feel is a lot easier to do in Python, but maybe complicated to do in T-SQL. And that's what we're going to show later on. Let me just check the time. I think we still have time. Yeah, still have 10 minutes, maybe 5-10 minutes. So let's take a look at artificial intelligence, which is just a good segue from the other one. So open source packages you can do, right? So right now, Azure already have cognitive services. They have vision, speech, language, search, and knowledge services. A lot of algorithm already available for you as a service in Azure Cognitive. So, and there's a lot. There's more. I think there's more than 20 already developed algorithm in cognitive services. So you don't need to recreate. You can just consume these services, right? So let's take a look at how we can do that in database. Remember, the execute external script allows you to bring packages. So that's why I said it's not just limited uh, to those algorithm. It's not just limited to just machine learning. Here's what you can do. Let me just go back up. Um, So remember earlier in this slide, you need to enable execute external script enabled for your SQL Server so that you can use. Let me just go to wide world importers. let's here you can you can check what languages are loaded on your uh, SQL Server by checking on the external language files. So here you can load extensions on SQL Server. By default, R and Python is installed. That's the one that you chose when you do the installation. Here I already loaded Java extension, but if you want to load other languages, or for example you want to load Java, you just need to drop any libraries that are related to that before you can drop the external language, and then you can create from it. You can create the language. You just have to bring the extensions, the Java language extensions. Here, the DLL for Java, and just this one, it opens you to a lot more possibilities of hosting other DLLs, other packages, so other libraries, so other languages. So that will create the language that will allow you to create store Java libraries. So if you look, well, let me show you quickly. If you look at my server, I have these libraries for R. So that means I can use all these packages in my R scripts, right? So by default, you can create your own packages, you can create your own libraries, and load it in on the database for whatever data processing or operations that you would like to use. So here, for example, in our example here, I'm gonna use regex. So uh, I have a table of I have a simple table here with PII information. I can see some social security numbers here. For example, I wanna filter those data using regex. Now, I'm not saying it's impossible to do in T-SQL, but it's gonna be complicated to write a T-SQL for regular expression, and it's a lot easier to do it in Java. So what you do is, I have a let me see. Do I have it open? I have a let me just do I have the Java example. For example, I have here the Java. I have a Java script here for regular expression, for processing sentences and finding regular expression. So what I just need to do is convert it into a jar file and then load it into my database. I already have the Java language. I load it as a jar file to create a library, regex library, and then use that package, the regex sample package, to process my data and parse out the regular expression. So here I filtered out all the all the entries in social security number. So that opens you up to a lot of possibilities, right? So we're talking about AI. There's a lot of services in. I think there's a session for cognitive services later on. You can check out all the list. But if you go to the portal, there's a lot of cognitive services available for you. Here, I'm using a sentiment text analysis, text analytics uh, cognitive services. I'm just gonna get my key and my endpoint, and then I have a Java script here. I'll just put my host and then my access key. And now what it will do is what it will do is, and then I'm gonna load that. So we have this table, for example, of product reviews. Oops, let me reopen those. Okay, I got 8 minutes. Let me. So let me open it back up. So I have a where am I? Oh, I have a product review here that I want to get this the sentiment analysis with. So what I will do is load the get the service from from Azure Cognitive Services, then create a jar file for it. It will connect. What it will do is it will pass the data. It will analyze it using the cognitive services in the cloud, and then send me back the result. So now I have a sentiment analysis here. First, I have a score. Now that's well and good, right? Now you have AI on your SQL Server. You put it in a package, in a Java package, and then you can call it from your SQL Server. Now you have AI on inside your database. But if you look at the so that's one way. So, for example, it's named Louis here because I have another example there for Louis, but we don't have enough time. What happens is you have a cloud service for cognitive services where you pass your data. So you execute the T-SQL, goes to the SQL Server to the SQL Server database. It launched the satellite program for the language that you're using, in this case Java, and then that Java script calls the cognitive services from the cloud to process your data and then give it back to you and serve the results to your SQL Server in T-SQL. Now that's well and good. You already brought AI to your SQL Server, but if, for example, you're a company with all the limitations that we mentioned earlier, you still have a problem because your data went out to the cloud, right? So how can we fix this? For Azure, for cognitive services, we maybe I should just show you guys. What we can do is you can create containers. You see here, I have a container for language for Louis. So Azure Cognitive Services allows you to create container of that service and bring it inside your package it and bring it inside your environment. So here I have a local container for Louis that can do everything that the cloud service Louis can do, but in my local, in a container, in a Linux container, in my environment. So if I do that, and the only thing I need to change is, if you look here, I already have them commented out. We just need to replace it with the string host for your static uh, for your for your for your local container. It's the same thing. For example, if you operate the Java, it's the same thing. You have a local string for your container here, and the IP for your container, for your app ID IP. So that will essentially lets you do this. So instead of your data going out to the cloud, you have it in your local. You don't need to go out to the cloud. You still meet your regulatory requirements. You still need your security requirements, but you are using AI in your database within your environment. So, and that's how you can bring AI to your SQL Server. Now I think Cognitive Services Container is now in general availability. Uh, some of some of the services are still in gated preview, so you need to apply for it. You need to submit your request to be able to use it. But most of the key ones are already available. So that's one way of bringing AI to your local, to your SQL Server, to your on-prem by using cognitive services containers. So it's disconnected from the cloud. It meets your regulatory requirement. It's a cloud application in on-prem. So all of everything that you've seen here in this session, you can find some of the most of the scripts, some of the uh, setup on SQL workshops. If you want to explore more, or you can check out the docs section for machine learning services, or yeah. So in summary, so SQL Server 2019 services for in database machine learning. Use ML services if you want to stay within your database. The extensibility framework that we have for ML is not just for ML, but for other packages too. So you can do more processes in terms of data processing and data operations. Use the language that is easier to code for the requirements that you have. And you can run AI on SQL Server using the same ML extensibility framework, using the packages, using jar files, and you can bring AI on-prem with Azure Cognitive Services containers. I think I hit. There you go, just in time. So if you have any more questions, if you have any questions, or if you want to connect after this, make sure to you can reach out to me. You can check. You can reach out to me to any of the social media channels in your screen. Let me just check if we have. Do we have questions right now?
You're back. I'm back. I think there are no other questions, and I think we should be good.
All right. So that's all for just in time, 11:39. So
Yep.
I have 1 minute. So
Perfect.
yeah.
Yeah, go ahead, and I think we'll conclude the session. And thanks for pressing in this Pio. Thank you.
All right.
Okay, guys, please wait for the next session coming up. Stay tuned. Thanks.
All right. Thank you.